Okay, well, I wanted to respond to your questions, and specifically looking at number 3, 5, and 9. So let's look at number 3 first. What we've got here is a situation where we've got a three-dimensional object, and the figure is sliced to give a cross section. So in other words, this little plane here, and that's how you do a cross section, is you take a plane, which is 2 dimensions, and you kind of cut a slice out. It's kind of like if you just sliced off the top of this object. Then the top part, or the shaded part here in the middle, would be the cross section. So if you look at that figure, you have to look at how many sides does this have, and there's 1, 2, 3, 4, 5, which makes it a pentagon. 5-sided figure is called a pentagon. If it were 6-sided figure, then you would call it a hexagon or something else. Pyramid is actually a 3-dimensional figure, and a rectangle would be a 4-sided figure. So I hope that helps with number 3. Okay, now we're looking at number 5, and we've got a 3-dimensional figure here. The problem says use formulas to find the lateral area and surface area of the given prism. This is going to be two different quantities. The lateral area is one quantity, and then the surface area is another one. And it says round your answer to the nearest whole number. So we're going to go through both calculations here so that there can be some understanding of this problem. Okay, so to help you understand this problem, I'm taking you back to lesson 2 from unit 5, and just kind of review exactly what we're talking about when we're talking about lateral area versus just surface area. So if you'll look at what we have here, first of all, here's a prism, and a prism is any polyhedron that has two congruent parallel faces, and those are called the bases. When we've got this particular one here, we've got the bases happen to be pentagons. Okay, everything else, the lateral faces are the ones that are not bases. Those are called lateral faces, and they are typically going to be in the shape of rectangles. Okay. Then we've got the altitude of a prism, and that's just a perpendicular segment that joins the planes of the bases. In other words, it's just one edge of a lateral face going up and down here. This would be example of an altitude. Okay. And then the height of the prism is just the length of the altitude. Now, what's the difference between an altitude and a height? The altitude is the actual segment. It's actually what you're drawing there. The height is a number. It's the length of the altitude. So we use the length when we make calculations, but we talk about the altitude, we're pointing to a figure. All right, so let's move on to, we could talk about a right prism and an oblique prism, but that's not really important for this problem. We're going to talk about the lateral area the lateral area of a prism is just the sum of the area of the lateral faces. Okay, well, what's a lateral face again? Lateral face is just those rectangles going around. It's not the bases, it's everything except the bases. Okay, now one way we could do that is to, if we flattened everything out, we could find the complete surface area of a figure by drawing its net. Okay, now the lateral area, we would just have to subtract off the two bases, which would be these two side flaps. That's one way to do it. But the main thing is, if you're just thinking about what that is, lateral area is just the surface area of the lateral faces, and then the total surface area includes the base area. Okay, so let's go back to the problem and work that out. Okay, so here we are back at the problem. We have the parallel bases in this case happen to be triangles, Okay, so when we do the lateral area, we don't want to include the area of those two triangles. We want to include the area of this top rectangle, the side rectangle, and the bottom rectangle. So for the lateral area, we're going to start by taking, let's look at this top rectangle, which is 10.82 times 26. Okay, next we're going to look at, let's look at the bottom rectangle, which is that dashed line coming over here. And that's going to be 26 times this length here, which is 9. So we're going to add that to the area that we just put in. Then we add the area of the triangle on the left side here, which is 6 by 26. Or actually, yeah, 6 by 26. It's this little piece on the back here. Okay, so the total that we end up with when we multiply this out is going to be 671.32. Okay, now recall that we were wanting to round this answer to the nearest whole number. Nearest whole number would be 671. This is going to be rounded, so it's not exactly equal. It is approximately equal. So 671. Now if we look at the two different, we have two different answers that have 671. This one and this one. Which means we're not done. We found the lateral area, but now we need to find the surface area. That means we've got to add in the area of the bases. So let's do that. One of the bases here is going to be 6 by 9. So if we add in 6 times 9 times a half, because it's a triangle, 1/2 base times height. And then the upper triangle is going to be the same dimensions. Okay, so we're really adding 54 to the 671, and that's going to equal 725. And I did a little faux pas here. We should always list our dimensions. This is meter squared, meter squared. Remember, the 2 up there means it's a square units, and that's because we're dealing with area. Now in this problem, everything's already been put in there, but if you had a fill-in problem, you would have missed part of the problem by not putting in the meter squared. Okay? Okay, so now we're going to look at problem 9. And problem 9, we have, the question is finding the slant height of the pyramid shown. And they call the slant height x, and then they show you where the x is. So this kind of helps having that as a diagram. But even if you didn't have that, there's two heights listed here. There's the height of the pyramid that comes from the base perpendicular to the base going up to the apex or the top point of that pyramid, and then the slant height, which goes from the middle or the perpendicular segment of the one of the segments of the base going up. So it actually lies in the plane of one of those lateral faces there, or one of the faces of the pyramid. So how do we find that? Well, there's a couple of ways that we can work this. We're dealing with right triangles here. So if you notice, since we know this is perpendicular, not a good drawing there, and then we take this segment, which goes halfway from the, it goes from the center out, which is halfway across that segment, then we know that this length right here is going to be 3.5 millimeters. Okay, so that's a right triangle. The hypotenuse of that right triangle is going to be what we're trying to find, which is that slant height. So remember, with a right triangle, we use the fact that a squared plus b squared equals c squared, Pythagorean theorem. We've got our two legs, so we have a and b. So this is going to be 6 squared plus 3.5 squared equals c squared. Now if you calculate this out, you're going to end up with 36 plus and 3.5 squared, and that gives us 12.25. We add those two together, we end up with 48.25 is equal to c squared. Okay, now we can't leave it at this because we're not trying to find c squared, we're ultimately wanting to find c. So if we take the square root of both sides of this equation, this will give us c, and all we're left to do is find the square root of 48.25. Now obviously this is not a perfect square, so we're going to have to round it. So when we take 48.25, put it in our calculator, we'll end up with 6.946221, and etc. It goes on from there. So 6.946, and then it goes on from there. But the question, oops, what's happening here? Okay, well, I apologize. It looks like for some reason everything just disappeared off my screen. So what we had as our final answer was 6.946, and then a whole bunch of digits after that equal to c. We're supposed to round to the nearest tenth, which means this is the tenths column. If this is a 4, that means we have to round down. So our answer is going to be 6.9 millimeters, which is this one right here. I hope that gives a good explanation of this type of problem.